In the second part of 4.5, we're going to connect what we did with fractional exponents, and now we're going to have fractional negative exponents. So again, we're looking at this example. We have 4 raised to the negative 3/2. And the first thing I want to do is get rid of that negative exponent. So to do that, I have to reciprocate my base. So I have 1/4 raised to the positive 3/2. And now this exponent must apply to the numerator and the denominator. So I have 1 to the 3/2 over 4 to the 3/2. Well, 1 to the 3/2 really means, remember the denominator tells me I'm taking the square root of 1 and cubing it. Well, that doesn't really matter because 1 to any power is 1. But if I write the bottom as a radical, remember the denominator tells me what the index is and the 3 tells me what the power is. So this really means the square root of 4 all to the power of 3. This is going to be 1 over the square root of 4 is 2 cubed, and 2 cubed is going to be 8. Similarly, in my next example, I want to get rid of the negative exponent. So again, I reciprocate the base, and now my exponent becomes positive. So this really means 27 to the 2/3 all over 8 to the 2/3, which really means the cube root of 27 squared over the cube root of 8 squared. Well, the cube root of 27 is 3, and 3 squared is 9. The cube root of 8 is 2, and 2 squared is 4. So my final answer would be 9/4. Okay, let's try these next two without a calculator. So again, I have I have 8 to the negative 2/3. So again, I want to reciprocate the base because I want to get rid of my negative exponent. So it's going to be 1 over 8 to the 2 over 3. So this really equals 1 to the 2/3 over 8 to 2/3. Well, 1 to the 2/3 is 1. 8 to the 2/3 really means the cube root of 8 squared. And the cube root of 8 is 2, and 2 squared is 4. So my final answer is going to be 1/4. I'm hoping you're understanding that I'm doing this one step in my head here. I'm taking the cube root of 8 is 2, and then applying the power. 2 squared is 4. In the next example, again, I want to get rid of my negative exponent, so I have to reciprocate the base. So 16 over 9 to the positive 3 over 2, which really means 16 to the 3 over 2 all over 9 to the 3 over 2, which really means the square root of 16 cubed over the square root of 9 cubed. And some of you might be saying, well, why didn't I write the 2 in? Well, remember, if there's no number there, it's assumed to be the 2. Okay, so the square root of 16 is 4, so this really becomes 4 cubed. The square root of 9 is 3, and that's 3 cubed. Square root of 4 to the power of 3 is 64. 3 to the power of 3 is 27. So that would be my final answer. Okay, I encourage you to pause the video and give these two a try. Okay, hopefully you've had a chance to do these. So again, I want to get rid of my negative exponent, reciprocate the base. So 1 over 16 to the 5 over 4. So this is 1 to the 5 over 4 all over 16 to the 5 over 4. 1 to the 5 over 4 is 1. 16 to the 5 over 4 is the 4th root of 16 to the 5th. This is 1 over. Now be careful, the 4th root of 16 is not the square root of 16. The 4th root of 16 is 2 to the 5th. It should be 1 over 32. All right, I'm going to erase this now. If you need to watch it again, you can rewind the video. And I'm going to look at the second question. So again, I want to get rid of my negative exponent. So this is really going to be 36 over 25 to the 1/2. And this one's pretty easy. This really means the square root of 36 over the square root of 25. Square root of 36 is 6. Square root of 25 is 5. So my answer is 6/5. Okay, let's take a look at an application here. Now, sometimes we need to use our calculator to evaluate some of these negative exponents. because in the real world, some of our measurements don't work out to be perfect fourths or perfect cubes. So we have technology to help us with this. So in this example, we have paleontologists use measurements from fossilized dinosaur tracks, and the formula V equals 0.155 s to the 5/3 f to the negative 7/6 to estimate the speed at which dinosaurs travel. In the formula, V is the speed in meters per second, and S is the distance between successive footprints of the same foot. And F is the foot length in meters. So F is in meters, S is in meters per second, and we want to use the following measurements from the diagram to help us out, okay? So if we notice, S is the distance of successive footprints. Okay, so S is the distance going from one footprint to the next footprint, okay? And it's telling us in this particular case, let's ignore the values that are given in the diagram here, but let's use these in the formula, okay? Technically speaking, these are supposed to be two different questions, but let's just combine them into one here. So technically speaking, it's telling me F is 0.3 and S is 1.5. So let's look at applying the formula. So let's start with the formula. So V, whoops, I should get to a pen here, not a highlighter. So we have V is equal to 0.155. Now S was given to me as 1.5. That's raised to the 5/3. And F is 0.3, so 0.3 to the negative, and I believe it was 7/6. Okay, we want to evaluate this expression. Okay, well again, first thing I can do to make my life a little easier if I want is I could write 1.5 as 3/2, but since I'm going to use my calculator, that really doesn't matter. Okay, but you could flip, because 0.3 is really 3/10. So if I flip that, that's going to be 10/3 to the positive 7/6. Now we're going to use our calculator. Why? Because there is no exact value of the cube root of 1.5, and there's no exact value of the 6th root of 10/3. So we're going to use our calculator to help us evaluate the whole power. So on my calculator, okay, I'm going to plug in 1.5 raised to the power of, and make sure you put a bracket around the power, 5 divided by 3. And on my calculator, I get 1.9656 if I go to 4 decimal places. This guy here, you might want to type in 10 divided by 3 first, which is 3.33333, and then raise it to the power in brackets of 7 divided by 6. And when I do that, I get 4.0740. Now, if I multiply these all together, 0.155 times 1.9656 times 4.0740. Okay, oh, I made a mistake there on my calculator. Let me try that again. 0.155 times 1.9656 times 0.0740. And this works out to be 1.24, and the velocity was in meters per second. So there's how you use your calculator to help you evaluate some expressions that aren't so easy to evaluate. All right, there is the end of your lesson. So there's your assignment. There's also a handout you'll get in class today as well. So give those a try, and if you have any questions, check the web page for the answers.